Hey guys, welcome to the review session. So today we will do some problems. We'll solve some problems which will be relevant to your exam, to the midterm exam, which will happen tomorrow. As I told you, let me say a few words about the exam. So the exam will consist of 5 questions. And I believe I sent you my previous midterm exam from last year, but this time this will have 5 questions and you will have a week to complete it. But I don't think this should take more than 2 hours. Anyway, let me get started and say a bit about the exam. All right. Okay, now, let me just, I forgot to, let me, just a second. So today is November 15. Oops, 20. Okay, that's it. Well, let me say a few words about the midterm exam before we do some problems. So the midterm exam will be available to you at midnight tonight. So it is available at midnight tonight. And you should send it to me and send it back to me via email. You'll receive precise instructions on how to do that and send it back to me by Friday, 11:59 p.m. Central Time, sharp. I will not accept any late exams. I wanted to let you know. So there is no way I will accept any late exams. So those of you who send it on Saturday, it's over. That's not gonna happen. You have plenty of time. You have 5 days to complete this exam, and it will take you no more than 5 hours. All right. You will receive at midnight precise instructions on how to send me back the exam and so on. I will not tell them here. Anyway, it will be a PDF, so you will send an email to me. You'll write in the title, you'll write your name and the midterm exam, and then you will attach the exam. The exam will be a single PDF file. But anyway, just wait for my instructions so that you can. All right, let me tell you a bit about the content of the exam. So the content of the exam, so those of you who are present here, I would like you to write your name on the chat. Yeah, exactly, so that I will take the attendance for this. And like I said, this is worth 5%. So this is, like I said, I'm giving extra 10% to the final grade for those of you who attend the review session. So if you attend one review session, you'll get 5%. If you attend both of them, then you will get 10% extra credit. All right. Now let me get back to the exam and say, so there will be 5 questions. So each is worth 6 points. Right? So in total, the total is 30 points. So it's 30% of your final grade. You should keep this in mind. And the questions will be, so the material is from chapter 1, includes chapter 1, chapter 2, and chapter 3. 1, 2, and 3. So this is what you need to know. So the last two videos that I sent you, right? They're not included in the material is not included for the midterm exam. All right. Now I would. Do you have any questions so far? Any questions regarding the exam so far? You can speak up. No, there will not be multiple choice. The second review session, it will be probably before the final exam, so it's probably sometime in December. I'll let you know. So the exam will be, I think it's on a Thursday, then probably the review session will be maybe on Tuesday or Wednesday, something like this, but probably on Tuesday before. But anyway, let's not talk about that now. Do you have any questions regarding this, the midterm exam? All right, I think, okay, that's good. We're good to go then. And now so I printed some my previous exams, and I would like to discuss that. I don't know if you have the chance to have a good look at it, but I would like to discuss some of the problems, in fact, maybe all of them, from my previous exam. And let me start with with problem 1. And by the way, this was in it was in class exam, and the time limit was 1 hour and 20 minutes. It was a little bit hard, but anyway. So this was midterm. So midterm exam. In fall 2019. And the problem says the following. Let me look it up. No, the time limit for this exam will be, you send it to me by Friday, just like I said here, 11:59 p.m. So no time limit for you, but I would suggest you do it in at most 2 hours. I think those of you who can do this, I think it's good. All right, the first problem is evaluate the following limits. Or show that they do not exist. So pay attention here. And the limits are the following. Not exist. So the first one is the limit as x approaches 2 of x squared plus x minus 6, everything over x squared minus 4. And the second one is the limit as x approaches 2 of x minus 2 over the square root of x minus square root of 2. Okay. I would like you to look at this problem. Think of it for a couple of minutes, a minute or two, and if you have some ideas, just let me know. So those of you who write your names, those of you who haven't written your names here in the chat, please write your names. So how would you approach this this limit? Does anybody have any idea?
You would factor out the bottom.
Exactly. So let's see what okay, before we go into before we do this factoring, first of all, I would like to settle what kind of indeterminate do we have? What is the indeterminate in the first one?
The denominator.
Yeah, but what is the indeterminate? So what kind of indeterminate do we have? So if we plug in x equals 2, what do we have?
4.
The answer will be undefined.
Yeah, but what is the undefined? This is what I'm asking. What? It's 0 over 0. Yes. So if you plug in, so the this limit, if you plug in, this is what you this is the first thing that you try. So when you have the limit as x approaches whatever, it doesn't matter. Then you plug in that number, and then when you plug in this number, you'll have 2 squared. So first thing you need to plug in x equals 2 into the limit. And we have, what do we have? We have that 2 squared, okay, let's write it, plus 2 minus 6, everything over 2 squared minus 4, which will give us what? 0 over 0. But this is undefined. So we need to do something here. Maybe we need to come up with something. And just like Matthew suggested, and somebody else as well, maybe we should factor the numerator and the denominator as well. So we have that. So we factor both the numerator and the denominator. And we have, let's see, what do we have? So we have, let's write it, the lim as x approaches 2 of x squared plus x minus 6, everything over x squared minus 4. And now we will, so we'll put here the lim in front of it. So it will be lim as x approaches 2. And now we will factor the top. So the top will be factored as what? Can you tell me? It will be x minus 2 times x plus 3. And the bottom will be factored as what? Can you tell me?
X minus 2 and x plus 2.
Exactly. So it's x minus 2 times x plus 2. Okay. Now we're in a good position because look at these two guys. They just go away from here. So this would be nothing else than just the limit as x approaches 2 of x plus 3, everything over x plus 2. And now you do the same thing. You plug in x equals 2, and now this it will be 2 plus 3 over 2 plus 2. And this will be we're in a fortunate position here, so this would be 5 over 4. Right? Does this make sense? Is it clear for everybody? Okay.
Yes.
Now let's see the second one. If you plug in x equals 2 in the second one, what kind of indeterminate do we have? 0 over 0 again, exactly. So again, when we plug in x equals 2, we get 0 over 0, which is undefined. All right. Okay, so maybe we should do something else. What can we do? Can you tell me?
We can write the numerator as root x squared minus root 2 squared and then
exactly.
like
So
factorize it.
So exactly, yes. Yes, Ariane, also Tejas, the same. Okay, but what do I mean by what exactly is the procedure called? It's called multiplication by the conjugate, right? I think I've done a couple of examples in the videos. I would suggest you go back and see the videos. I don't recall exactly which video, Exactly. Yes, you rationalize the fraction. It's exactly the same thing. So multiplying by the conjugate, we have that the lim as x approaches 2 of, and now let's see, x minus 2 over the square root of x minus square root of 2. And now when we multiply by the conjugate, and let me write it here with a different color, the conjugate of the square root of x minus square root of 2 will be square root of x plus square root of 2. And this will be nothing else than square root of x minus square root of 2 times x minus 2. Everything over, and here on the bottom we have, again, square root of x minus square root of 2 times square root of x plus square root of 2. But now if we do a little bit more algebra here, this would be nothing else than just the limit as x approaches 2 of, let's write it in this way, so it's square root of x minus square root of 2 plus square root of 2. Oh my. Okay, I did a mistake here, sorry about that. So this would be minus here. Give me one. And here I should put plus and plus. Okay. I think now it makes more sense because I multiply by square root of x plus square root of 2 times x minus 2. Everything over. This guy, the bottom will be equal to what? Can you tell me?
X minus 2.
X minus 2, correct. And guess what? Magic happens. Look at this 2. They'll just go away. So this would be nothing else than just the limit as x approaches 2 of square root of x plus square root of 2. And now you can plug in x equals 2, so you'll get square root of 2 plus square root of 2, which is 2 square root of 2. And that's the problem. That's the end of the problem. So you see, that's the solution. Does it make sense for everybody? Okay. I will be very happy if I see more of you being active. I see now 42 people. Those of you who appeared a bit later on, please write your names on the chat so that I can see it. Because otherwise I will miss the attendance. Okay, that's good. Yeah, I see. Look, okay, good. All right. There were 39, now they're 42. So, okay. All right. So this was the first problem, was considered to be the easiest, I would say. Now let's see another one, which will be very similar. Again, so this is problem 2. Now so problem 2. Again, the same midterm exam. So midterm exam, fall 2019. And the problem says the following. Let me look here. So it says find the value of this constant C for which the function is continuous. This is important. Now we need to see what continuous is at x equals 2. So it is continuous at a single point. And justify your answer. And the function is a piecewise function and is given by the following. So it's f of x equals x squared plus 3 if x is less than 2, and c times x minus 1 if x is greater or equal than 1. Okay, this is the problem. Think about it for a minute or two. And if you have some ideas, please, but just after a minute or two, because I want people to think of this problem. I want you to read the problem very, very carefully. Okay, before we get started, I want you to tell me, so we need to find the values of C, right, of that constant. Look at them here, for which this function is continuous. So at the point x equals 2. Well, can you tell me what this means? So when f is continuous, so f, okay, recall that and let me write it with red actually, that f is continuous. So this is continuous at x equals 2, let's say. So at this point x equals 2, if and only if what? Can you tell me?
Limit is equal to the right hand limit is equal to the value of the function at that point.
Exactly. If we have this, so the limit, the left hand limit as x approaches 2 of f of x is the same as the right hand limit. Yes, exactly. Also Peyton said yes. Of f of x, and also keep in mind it's actually equal to the value at x equals 2. So this is these are the conditions that we need to verify in order for our function to be continuous. And we know that our function is continuous at x equals 2. And we'd like to see for which values of c this function is continuous. In other words, for which values of c we have that the left-hand limit at the 2 is the same as the right-hand limit at 2 and is the same as with the value of f at 2. Now, what we need to do is just to compute these three things, right? Now, let's see the first one, the limit as x approaches 2 from the left of f of x. Let me remind you that this guy here, okay, let me mention this guy here is nothing else than just x approaches 2 and x is less than 2. Okay, this would be equal to, can you tell me is the limit as x approaches 2 minus, and I will replace by what? Which branch of my function f, which piece is defined for x less than 2?
X squared plus 3.
Exactly, x squared plus 3. So I'll put it here. And this would be, now I can plug in, yes, exactly. So this would be what? If you plug in, so it will be 2 squared plus 3, which will be 7. All right, that's great. Now let's look at the second one, limit as x approaches 2 plus of f of x. And again, let me remind you that this guy here means nothing else than just x approaches 2 and x for values which are greater than 2. So this would be equal to the limit as x approaches 2 plus of, and now I will replace by what? Look at the function again, how it is defined.
Cx minus 1.
Dx minus 1, correct. All right, and if I plug in 2 here, this would give me 2c minus 1. All right, great. And also now let's look at the value f of 2. Can you tell me what f of 2 is? Will be what? On which branch we have the number 2? On which?
X minus 1.
Cx minus 1.
Cx minus 1, right? So it will be f of 2, 2c minus 1. Exactly. And we replace it by 2. And now look at these three guys. This guy must be equal to this guy and this guy. So these should be equal. So in other words, f is continuous at x equals 2 if and only if 2c minus 1 equals 7. And from here, which means that that what? That C is 4. And that's it. Well, it's clear, right, for everybody, the problem? It's pretty straightforward, I would say. Now we can have 3 pieces. So maybe I could complicate it. I'll make it a bit more complicated. Maybe you'll have 3 pieces. The first 2 pieces will be for a number. Maybe I'll cook up some other number. But anyway, the procedure is still the same. All right. Now, I would like to jump on some other problems which will involve the derivatives. And maybe, and the first problem that I have in mind is the following. So the problem number 3 from problem 3, again from the midterm. Again, fall 2019, says the following. So find the derivatives of the following functions. So the first one, f of x is x to the power x, and g of x is cosine of x, everything to the power x. Ooh. So we've talked about this, how to compute these limits. Well, you didn't compute these derivatives. I don't think you had any. Well, we call this logarithmic derivatives. So I don't think you have any of these on the gateway, first gateway exam. But definitely, this should will appear on the midterm exam. Ah, you there? Oh, yeah, really? Okay. Anyway, I don't recall exactly the problems, but all right, think of this for a bit, for a minute or two. I see people from all around the world. Wow. Probably in Nigeria, for example, right now is like 3 a.m. or what time is it, Toby? Is 3 a.m., 4 a.m.?
2:35.
2:35 a.m., right?
Yes.
Wow. So let's see. How do we approach this problem?
We first put fx as y and then take log on both sides. So log y will be equals to x log x.
Exactly. So, so we'll take the log, right? So if we take the log, so let's look at the first one. So let f of x be x to the power x. So by taking the log, so ln of f of x, right, is nothing else than ln of x to the power x. But this is what is x ln of x. And now we take the derivative both sides. So by differentiating both sides, we have So let me write it slowly so that you can see. So it's ln of f of x and everything prime. Let me write it in this way so that you can see it better. Is x ln of x everything prime. All right, first, this guy is equal to what? Can you tell me? Now we apply the chain rule. So by the chain rule, this will be equal to what?
1 over f of x, or derivative of f of x over f of x.
Exactly. So you can write it 1 over f times f prime or f prime of x over f of x, right? Okay, that's great. And this guy will be equal to, and here we'll apply the product rule. And this guy will be what? Will be x prime times ln of x plus ln of x prime times x, which will give us what? It will be ln of x plus 1 over x times x. And this guy will be equal to, at the end, with ln of x plus 1. Right? That's beautiful. Are we done? No, not yet. So we know that f prime of x over f of x is this. So f prime of x will be nothing else than just f of x times ln of x plus 1. But f of x is x to the power x, so it's x to the power x ln of x plus 1. And that's the derivative. That's f prime of x, right? So the procedure is pretty standard. This is how we do it. Is it clear? Okay. Now let's see the second one. The second one is pretty similar. So we have that. So let g of x be cosine of x, everything to the power x. Again, we do the same thing by taking the log. The natural log. We have, let's see, so we have that ln of, let me write it here, ln of g of x is equal to ln of cosine of x to the power x. But this, by applying the properties of the log, this would be equal to x ln of cosine of x, right? And now differentiating both sides. We obtain, and let's see. So again, let me write it. Ln of g of x prime is the same as x ln of cosine of x prime. But this guy, by the chain rule, as you have previously seen, this is nothing else than just g prime of x over g of x. And this guy here, by the product rule, will be equal to x prime times ln of cosine of x plus x times ln of cosine of x prime. And this will be equal to ln of cosine of x plus x times ln of cosine of x will be what?
1 upon cos x into minus sin x.
So it will be, so 1 over cosine of x, right? Times cosine prime of x, right? And this will give us ln of cosine of x plus x times, well, yeah, cosine of x prime, which is negative sine of x, right? Times negative sine of x over cosine of x, which is tangent of x. So this guy will give us ln of cosine of x, minus, so minus x tangent of x. right? Sine over cosine is tangent. So this guy is nothing else than just, so let me, g prime of x over g of x. So this guy is equal to this. So finally, this implies that g prime of x is nothing else than just g of x times ln of cosine of x minus x tangent of x, which will be equal to cosine of x, or g of x, sorry, which is cosine of x to the power x times ln of cosine of x minus x tangent of x. And that's the derivative, this guy right here. Okay, that's the end of the problem. Is it clear for everybody, the procedure? They're pretty similar. I mean,
Seems easy enough.
okay, that's good. That's good to hear. I hope it's easy for everybody, not just a couple of you. But anyway, please feel free to stop me at any time when you don't understand something. So don't be ashamed of anything. Just stop me. So when you have a question or when you I don't recall exactly the lecture, but probably around lecture number 9, I think. I think I discussed there the logarithmic derivative. So look for the lecture when I talk about logarithmic derivative. I think it was 9 or 11. I don't recall exactly which one is, but I think somewhere around there. So these type of questions are part from the of what we call logarithmic derivative. All right. Now let me do some implicit differentiation, right? Since we talked about the tangent line and stuff. So let me do another problem. So problem 4. Again, this was given at the midterm exam. Just I think I did it separately. The logarithmic derivative is separate because I did not understand, but this is the schedule. You kind of have to do them separately. And even the limits with infinity, for example, I haven't covered them, so they will be separate. They put them at in the differentiation chapter. I don't understand why, but anyway, it is what it is. That's the schedule. I'll go with it. But if you ask me, I would do all the limits before discussing the derivatives and everything. So, but anyway, so again, this was a midterm exam, fall 2019. And in fact, I'll do a couple of problems of this type, or maybe I'll do 2 of them, which says the following: find, let me read it. Find the equation of the tangent line to the curve xy times x plus y equals x plus y to the 4th. At the point 1, 1. All right, as you can see here in this problem, you see we need to look at this guy, the tangent line to the curve. And we want to write the equation of the tangent line. This is so what we need to do is we need to find, so first we find dy over dx, right? So we find this differential by implicit differentiation. That's the word. And now let's see. So we have that. So we have that xy times x plus y is x plus y to the fourth. And now we implicit differentiate, or in fact, which is will be, this is equivalent. Let's do some algebra here. So this is x squared y plus xy squared is x plus y to the fourth. Okay. Now we have, so this implies that and now be careful here. So we d over dx of x squared y plus xy squared is the same as dx of x plus y to the fourth, right? And now by applying the standard procedure for differentiation, the sum rule, for example, this would be equivalent with d over dx of x squared y plus d over dx of xy squared equals d dx of x plus y to the fourth. And this will be equivalent with what? And now for the first one, we apply the product rule. So this is equivalent with d with dx of x squared, right, times y, right, plus dy over dx times x squared, plus, so this guy, look, this guy here is only this guy. And here I apply the product rule. So here's the product rule, right? Okay, and now I'm going to do the same thing for the second one. So plus, this would be dx over dx, which will be 1. So it will be y squared plus x times d, so dy squared over the dx, which will be 2y dy dx, 2y dy dx. This guy here is nothing else than this guy here, by the same reasoning, by applying the product rule. And now this will be equal to, let me write it, in fact, dx over dx, so this will be 1 plus, and this guy here, so this is this guy here, so this would be equal to dy to the fourth over dx, which will be 4y cubed dy dx. All right, finally, this will be equivalent with, let me write it here, this is equivalent with, so this would be 2xy plus x squared dy dx plus y squared plus 2xy dy dx equals 1 plus 4y cubed dy dx. And now we're looking for similar terms. We would like to see which one has dy dx. Look at this guy here. Look here, look here. And we're trying to separate these, right? And once we do so, this would be equivalent with, I'm going to write it directly. So this would be dy dx will be equal to, so 2xy, in fact, no, let me, okay, I'm going to write it like this. So it will be dy dx times x squared plus 2xy minus 4y cubed will be equal to 1 1 minus 2xy minus y squared. And finally, this will imply that dy over dx will be equal to 1 minus 2xy minus y squared over x squared plus 2xy minus 4y cubed. Okay, so we finally got this. We arrived at this. All right, that's beautiful. And now look, let's go back to the statement of the problem. Look what it asks us. We're interested to see what happens at this point here at 1, 1. So basically, the equation of, so we would like to find the slope of the tangent line, which is nothing else than dy over dx at 1, 1. So let's write this. So at the point 1, 1, the value of dy dx, which is the slope of the tangent line, right? That's what it is given by dy dx at the point 1, 1 is, now we will replace x by 1 and y by 1. So we'll have 1 times 2 times 1 times 1 minus 1 squared. Okay, which is 1 squared plus 2 times 1 minus 4 1 cubed. So this would be -2 over -1, which is 2. So that's the slope of the tangent line. We're not done yet. We need to compute the equation of the tangent line. So finally, the equation of the tangent line, is given by y minus 1, right? Y minus y0, which is 1 in our case, equals 2, which is the slope, times x minus 1. Or equivalently, you can write this as y equals 2x minus 1. So that's the equation of the tangent line. Right, it's pretty standard. So you'll have something like this in the exam. Something of this type, to find the equation of the tangent line of a curve at a point. Do you have any questions regarding this example? Is it clear for everybody? Any questions, or it's clear? All right, that's good. Unfortunately, I don't see, you have your cameras turned off, so I don't see your reaction. Usually when it's a face-to-face interaction, I can see. I can figure it out myself if you got it or not, or you didn't get it. It's easier for me to see, but now since we're online, it's a little bit harder for me to see your reaction. Anyway, okay, that's good. Now let me do another problem. Problem number 5. Again, this problem was given at the midterm. Okay, that's good. Please, like I said, like I said, I cannot see your reaction, so feel free to stop me when you can speak out when you don't understand anything. Unfortunately, this will be our only 2 interactions during the review sessions. Since the class was not scheduled, so it's an asynchronous class. So basically, we don't have a time schedule. It's just me talking by myself in the videos. It's kind of sad, but what else can I do? All right, so problem 5. Again, was given at the midterm exam in fall 2019. And it says the following. The Leaning Tower of Pisa, probably heard of it. Tower of Pisa. I would suggest you visit Italy when you have a chance, where you go to Pisa, and you know that Leaning Tower when everybody takes a picture close to it. Yeah, it's a pretty nice view. So the Leaning Tower of Pisa is 176 feet tall. A rock is thrown upwards from the top at 20 feet per second, right? The position of the rock at time t is given by, well, the position function, which is given by s of t, and this will be a quadratic function. This will be 16t squared plus 20t plus 176. And we're asked to do the following. How high does the rock go? And the second part B, and when does it hit the ground? Okay, I want you to look at this problem, think of it for a bit, and then we'll discuss it. I have plenty of other problems to do. All right, so how would you approach this problem?
The rock will be the highest when the velocity is 0. So you differentiate.
Exactly. So, exactly. So we need to analyze this a bit. So how high does the rock go? So basically, when you hear this, we're wondering at the peak, right? The velocity will be 0. All right, so let's, so the velocity let's just say v of t, right, is the derivative of s of t, right, the position function. Right? So let's just write this. So v of t will be nothing else than just s prime of t. And this is, okay, let me write negative 16 t squared plus 20t plus 176 prime. So this would be negative 32t plus 20. So that's the velocity function, right? As you can see, it depends on time. And now at the peak, the velocity is 0. In other words, this means that a v of t is 0 if and only if negative 32t plus 20 is 0, if and only if, well, t will be what? Negative 20 over negative 32, which is, well, how much is that? 0.625 seconds. Right? So we evaluate the function as, so the position function at that point. So as of 0.625 will be nothing else than just, what is it? So this would be equal to, anyway, 182.55 feet. Okay, that's it. You see? All right, let's see the second part. What does it mean, the second part? So we're asked to see when does it hit the ground. So what happens when it hits the ground?
Distance is equal to 0.
Which one?
Distance is equal to 0.
Well, be more specific, the position is 0, right?
Yeah.
Okay. So, yes.
When it's talking about the ground, since it's being thrown from the top of the building, would the ground be at negative the height of the building?
Negative the height of the building.
Because the rock's being thrown from the top of the tower of Pisa.
The height of the tower is measured from the ground.
Yeah.
Right? So the ground should be 0.
Yeah,
The top
exactly.
of the building is 176 or 175.
Yeah, exactly.
Yeah.
Yeah. Tejas is right. Is it clear now?
Yes.
All right. So basically, on the ground, the position. Okay, let me write it. So the position is 0. That's what you need to know. In other words, S of t is 0 if and only if, well, S of t is what? Negative 16t squared plus 20t plus 176 is 0. Anyway, this is a quadratic equation, so that you need to solve. And I'll leave it to you as an exercise to solve it. Right? And once you solve this, you'll get, so I'll leave it to you as an exercise. You'll get t to be 4 seconds. And that's the answer. Okay. Okay. Yeah, anyway, is it clear for everybody? The problem? All right, now let me do another problem. And let me just do the following problem. Let me find it here. Give me 1 second. Where is it? Give me what? Anyway. Give me a second. Oh, okay, here it is. So problem, this was not given so problem number, this is problem number 6. And the problem says the following: a plane is flying directly away from you at 500 miles per hour at an altitude of 3 miles. How fast, so the question is, how fast is the plane's distance from you increasing at the moment when the plane is flying over a point on the ground um, 4 miles from you. Well, that's kind of a long question, but anyway, look at the problem a bit. Try to understand it. So let's see. So let's draw a picture, right? So we have that the plane is flying directly away from you. So we will have something like this. So let me just draw the picture. So the plane is flying away. We have the following scenario. And it says that it's flying, so the altitude is 3 miles. So this guy is 3 miles. 3 miles, right? And what else do we have? So it's flying away at the 500 miles per hour. Okay, that's one thing we need to take into account. All right, and now I'll denote this by, let's say, x here, and this would be y, and this is 3. And we're asked to see how fast is the plane's distance from you increasing. So how fast is it going? So how much it will increase the distance from me when the plane is flying over a point on the ground 4 miles away from me. Okay. So now let's say a few words about this. So let's get the ideas straight. So because we need to analyze this a bit, because the plane is flying directly away from you, right? The rate of change, and this is important when we hear this word, and I think I mentioned this in one of the videos, the rate of change. When you hear the word rate of change, you always think of derivative, always. This is the first thing that comes to your mind. So the rate of change of x, this is important, is the speed of the airplane, right? Which is, so the speed is which is what? 500 miles per hour. So in this case, this would be nothing else. I'm going to write it here. dx over dt is 500, right? It's miles per hour. All right, I want you to look at the statement. Look here, plane is flying directly away from you at 500 miles per hour. So that's the rate of change, which is nothing else than just the derivative. Okay. All right, now let's analyze what happens with the distance between me and the plane. So let's write this. So the distance between you and the plane is y, right? You see, I am here, so the distance here is the plane, right? So here is the plane. All right, and now let's look at this triangle here. If you look at this guy here, this is a right angle triangle, and our good old friend Pythagoras. By the way, did you see, since we're talking about Pythagoras, did you see this joke with social distancing? When two guys are like this, it's 1.5 feet away. Two guys are like this, and also in the diagonal is the same 1.5 feet away. Yeah, man. And next to this picture, it was something like the day that Pythagoras died. Well, he died like more than 2,000 years ago, but yeah, that was a funny one. If you don't know it, I'll send it to you in an email. Because Pythagoras, so by Pythagoras Theorem, we have that, well, look at this right angle triangle. What do we have? We have that what? Yes, I'll send it. I'll send it. It's a pretty classical. You can just Google social distancing Pythagoras. In fact, let me do it. Let me see if you Google it, you'll let me see. So show social distancing Pythagoras, and you'll find out that picture. It's quite funny. Yeah, exactly. Stay 6 feet apart. So like this in diagonal and like this. Yeah. And in fact, it says San Francisco put these sign-ups. It's pretty surely petty to the point out that per Pythagoras theorem, these people are standing just 4 feet apart. Yeah, anyway, you'll find it anywhere. All right, now let's get back to our, these are actually signs, they put it everywhere. And so you can see how embarrassing this is. People don't know even something basic like Pythagoras theorem. But it was quite funny when I saw it. Anyway, let's get back to our problem. So by Pythagoras theorem, look at our triangle, right? It says what? It says that, well, we have two legs here, x and 3, and the hypotenuse is y. So we'll have that x squared plus 3 squared, right? Equals y squared. right? That's the Pythagoras theorem. So now this will be equivalent with x squared plus 9 equals y squared. And now guess what? You can, we want, so keep in mind that we want dy over dx at x equals 4. So keep in mind that we want this. So what are we going to do here? So we're gonna implicit differentiate, right? So by implicit differentiation, oops. We have that, let's see, d over dx of x squared plus 9 is the same as, in fact, over dt, sorry. Here I made a mistake, it's dt here, sorry about that. Dx over dt at x equal, at x, wait, what am I doing here? dy over dt, Jesus. Dy over dt, okay, at x equals 4. So here I have dt. So I differentiate. Oh my. And this here will be d of y squared. Okay. So this will be equivalent with, right, with 2x dx dt. 9, the derivative of 9 is 0, will be equal to 2y dy dt. All right, beautiful. This will be equivalent with, if we do some computations, dy dt will be x over y dx dt. And let's keep this equation in mind. And now at this point, at x equals 4, and we know that y is 5, right? We get that, so at x equals 4, y will be 5, right? Y is 5, again by Pythagoras. Let me mention here, by Pythagoras, our good old friend. So dy over dt, it's nothing else than 4 over 5 times, and we know that dx over dt is 500, right? Times 500. And this will give us 400 miles per hour. And that's the answer. Right? It's again pretty straightforward. The only thing you need to interpret is if you look at the picture, I think it's quite clear, right? Is the problem clear for everybody? All right. Now, let me do another problem. Problem number, what was this? This was number 6, number 7. Okay, let me see. Where were you lost? Here, when we took the derivatives, here at the box, here you're lost? After the box. After or before?
Where you say at x equals 4.
Yeah. Okay, at x equals 4. Look at this guy here. When you plug x equals 4, then you see you have y will be 5, right? Because 4 squared, which is 16 plus 9 will be 25. 25 is y squared, so y will be 5, right?
Oh, okay. I see.
And that's it. Okay.
Thank you.
Sure. Any other questions? I'm actually happy that you guys ask a lot of questions. That's good. This means that you're not getting bored, at least some of you, which is good. I'm trying to be as entertaining as possible. You know, some people, when I do, because, you know, 2 hours can be exhausting. So maybe I should crack up a joke here and there. But anyway, now let me do another problem. Problem number 7. And this was, it's similar to problem 6. I would say a little bit harder, and I will explain why. And it was an exam problem. Man, now that I look at the exam, some of the problems were harder. Poor guys, I killed those guys last year. Wow. So this was a midterm exam. The midterm exam was way harder. So what you see here, these problems was way, way harder than the final exam. Anyway, if you ask me, my personal opinion, I don't think the exams should be like very easy. But anyway, that's just my personal opinion. All right, let's see the problem. Like I said, it will be similar, but there will be something tricky here, and I'll explain. The problem says the following. One car, so this time we don't have a plane, we have a car. One car leaves a given point and travels north at 30 miles per hour. Another car, pay attention here, leaves, okay, and I'm gonna write this so that you, I would like to emphasize this. 1 hour later, and please look at this very, very carefully. So this car leaves 1 hour later and travels west at 40 miles per hour. Now we're asked at what rate. When you hear the word rate, you imagine what you think of. So at what rate is the distance between the cars changing? So you see, you have these magic words, rate and change. At the instant the second car has been traveling for 1 hour. Okay. All right. So let's analyze the problem first. In fact, I would like to give you 1 minute to read the statement very, very carefully and to see why it's a bit tricky. All right, let's see. So you see, I have one car. Let's read very, very carefully the statement of the problem. Like I said, the problem is a bit tricky because we have two cars. One car travels north. So let's emphasize this. Travels north and at 30 miles per hour. And another car leaves 1 hour later, will be important, and travels west at 40 miles per hour. And now we're asked at what rate is the distance between the cars changing? Well, basically, we're asked what is the derivative. But anyway, let's set up the problem by extracting the information in terms of variable x, y, and z. So I'm going to just draw the following picture. Sometimes, in fact, not sometimes, when you have these kind of problems, it's very good to draw a picture to see exactly what's going on. So let's see. So let's draw the picture. So of course we'll have a right angle triangle. So here will be x, here will be y, and here will be z. And let's look at the, so you see, let's analyze the first sentence. One car leaves at a point and travels north at 30 miles per hour. So the car is moving, right? So we will have that. So in the first sentence, we know that the car is traveling, so it's moving. So imagine that the car, the motion is this. So you see, the position of the car is described by x of t. So keep in mind that these will be functions of t of time. This is very important. So you see, because they're moving. So we know that dx over dt is 30 miles per hour, 30. And x of t is what? Is 30t. So, right? And also, if we look at the second sentence, let's analyze the second sentence. And this will be important because I would like you to distinguish. So look at this. Another car leaves 1 hour later. So the motion is what? Can you tell me? And travels west, so the car will travel west, right? So y of t, you see this, the second car. So x of t will travel north, right? North, south, west, and east. Will travel north, as you can see. Oh, x of t, so that's the first car. If you don't like x of t, you can write car 1 of t if you want. But anyway, I wanted to put x, y, and z. So the first car is x of t, the second car is y of t, and the second car travels north. So, and it says that the second car leaves 1 hour later and travels west. So dy over dt will be 40. And what is the motion of y? Can you tell me y of t will be what? In fact, I would like you to tell me. If the motion of x of t is 30t, y of t will be what?
$40t.
40 into t plus 1.5, no, point.
No.
3 upon 2.
40t minus 30, no. It's 1 hour later.
40 into t plus 1.
It will be 40 times t minus 1. Because it's 1 hour later, so I'll lose an hour. Do you understand? So here it starts 1 hour later. That was a trick here, and that's important. So many people didn't solve this problem, so because this will be important here. Does this make sense? Is it clear for everybody? Okay. What is the goal? Let's look at the picture. Let's see. The goal is look at the question. At what rate is the distance between those two cars? So it's quite clear what it is. We need to find, so z of t, right? Or maybe we need to find to put 30t plus 1. Ah, okay, if you put 40t and you put on the first one 30t plus 1, that's what you mean, Luca? It will be the same, exactly. Yeah. But anyway, that's a little bit, I wanted to analyze it word by word here. So, but this anyway, it will be the same. And now the goal is to find dz over dt at t, let's see, at t equals what? You see? So we want to see at what rate is the distance between the cars changing at the instant the second car has been traveling at t equals 2, exactly. This is important. At the instant the second car has been traveling for 1 hour, exactly, t equals 2. Okay. Now it's quite clear what to do. Look at the picture. Again, our good old friend Pythagoras. So by the Pythagoras theorem, we have that, what do we have? So we have that x squared plus y squared equals z squared. So x squared plus y squared equals z squared. But pay attention, these are functions of t. And now, let's see, at t equals 2, x of 2 will be what? Can you tell me? Look how x is defined. Look at how y is defined. So x of 2 will be
60.
60. And y of 2 will be
40.
40. Correct. This is important. So by the Pythagoras theorem, this will give us, so this gives us, pay attention here. Here, this is x of t, y of t, z of t. So I can take t to be 2. So this gives us that z of 2 will be the square root of 60 squared plus 40 squared, which is, oh my goodness, approximately, does anybody have a calculator? Let me see. Give me 1 second to look it up here. All right, that's beautiful. 72,111. Okay. Okay, that's good. And now let's go back to our equation. Look at this guy here by Pythagoras. And now let's implicit differentiate this. So by implicit differentiating, let's call this star. So by implicit differentiation of star, we have, let's see, what do we have? So we have that. So let's write it. So we differentiate this with respect to t. So this would be equivalent with what? With 2x dx dt plus 2y dy dt equals 2z dz dt. Or if you want, or equivalently, this will be equivalent with what? So the 2 will go away. So it will be x dx dt plus y dy dt equals z dz dt. And if you want, this will be equivalent with, we keep in mind our goal. Look at the goal. This is right here. We want to find dz over dt at t equals 2. So now we will write to express this guy in terms of the others, because we know what's going on with the others, but we don't know what happens with dz over dt. So this will imply that dz over dt is what? Is x over z dx dt plus y over z dy dt. And now we can replace this, so this would give us, so so x is 60 over 72.111. Dx over dt was what? 30 plus y over z, which is 40 over 72.111 times 40, right? dy over dt was 40. So let me recall you that this was 30 and this was 40. So finally, this would give us approximately, how much is this? Oh my goodness, if anybody has a calculator, how much it will be, what is this? Let me see. So this is 47.150 miles per hour. Anyway, it doesn't really matter. I don't care about this. You can leave it just like this. Yeah, 47.2. Okay, 47.2. That's the problem. Is it clear for everybody? The problem, it was a bit tricky. It wasn't, but anyway. Anyway, you will have time to analyze the video. Now, last but not least, I would like to discuss one more problem, which is a little bit more involved, I would say. So this would be problem number 8. And I think after this, I'm going to stop. So problem 8. And indeed, this was a midterm exam. In fall 2019. And the problem says the following: show that the equation x cubed plus x plus 1 equals 0 has at least one solution in the interval -2, 0. Okay, I want you to look at this problem a bit. I think I've done 1 or 2 examples of this kind. In one of the lectures, when we talked about intermediate value property, when we talked about continuity. So we did a bunch of equations. I think there was a trigonometric equation as an example that I did. So how we, again, this is pretty standard. You see, when you have something like this, has at least one solution in some interval, right? You think of intermediate value property. So the moment when you see this, we think of the intermediate value property and continuity. And what do I mean by that? So the idea is to consider the continuous function f defined on a -2, 0 real valued, and this is given by f of x is x cubed plus x plus 1, right? And we would like to show that, so the statement of the problem is equivalent with showing that the function f has at least one 0, at least one 0, or root, whatever you want to call it, in the interval -2, 0. So that's what we need to show. So f has at least one 0 in this interval. And now we will employ the intermediate value property. So now what do we know about a continuous function? A continuous function that goes from negative to positive, it has to go through 0. So in other words, let me remind you that f is continuous. This implies that f has the intermediate value property, the IVT. So this is what I call the intermediate value property, which basically says that if f of, let's say, alpha times f of beta is less than 0, right? For two values alpha of beta, then there exists an x naught in this interval alpha beta such that f of x naught is 0. So that's what it means for a function to have the intermediate value property, more or less, but that's what you need to know. So any continuous function that satisfies this property here, this guy here, it will follow that it will have a 0 in that interval, right? So in our case, look at the statement of the problem. We're asked to show that f has at least one root in the interval -0, 2. So what do you think we need to do? We need to do what? Can you tell me? Look at what I said. We need to evaluate what? The function f at the endpoints of the interval. So we need to evaluate. We need to evaluate the function f at the endpoints of the interval -2, 0. So in other words, we need to do what? We need to see what f of -2 is, what f of 0 is, and we would like to see if their product is negative. If it is, then by this guy here, by what we said here, it will imply that f has a 0. So let's see, f of -2 will be what? f of -2 is -2 cubed, right? Exactly. Minus plus -2 plus 1, which will be -9, which is negative. And f of 0 is, what is it? Is 1, which is positive. So f of 0 times f of -2 is less than 0. You see, I have this condition here. This one boxed in green, right? So by the intermediate value property, there exists an x naught in this interval -2, 0, such that f of x naught is 0. But who is f of x naught? Well, let's go back. Is x, look at it here. It's right here. Is x cubed plus x plus 1. So this will be equivalent with x naught cubed plus x naught plus 1 equals 0. And we're done. That's it. So this equation has a solution x naught in the interval -2, 0, such that x naught cubed plus x naught plus 1 is 0. Did you understand the idea? Is it clear for everybody? I've done a couple of examples. Maybe I think 1 or 2 examples. I think you should look it up for, God, no, I don't know exactly the lecture. Yeah, oh, so once again, let's look at the problem. You see, look at the statement of the problem. So I have this equation. It can be any equation, it doesn't matter. So it just happened to be a cubical equation. So this equation, x cubed plus x plus 1, I want to show that it has at least 1 0 in that interval. So you consider this function, f of x is x cubed plus x plus 1. You know it's a continuous function. Since it is a continuous function, it means that it has an intermediate value property. And we know from the intermediate value property that it means that if I have a negative value of f and a positive value of f, then I'll have a 0 between them. That's what you need to know. From negative to positive, it will have to go through 0 if the function is continuous. This function is indeed continuous because it's an elementary function, it's a cubical function. And now what you need to do is just to evaluate this function at the endpoint on the interval on which you want to show that there exists at least one solution, right? So what you do is you evaluate this function f, that is x squared, x cubed plus x plus 1 at -2 and at 0. If one of them is negative and the other one is positive, then between them you'll have one that will be 0. That's it. That's the end of the story. Does it make sense? All right, that's good. Keep that in mind. Any continuous functions that goes from negative to positive, it has to go through 0. You cannot avoid 0. So if you have from -100 to +100, in the, or I don't know, from 0 to 5, and you know at 0 it's negative, at 5 is positive, it will have to go through 0 at some point. One value between 0 and 5 will be 0. So that's what you need to know about this. I hope it's clear. Okay, guys, I think I'm gonna stop here with the review session. I hope it was useful for you. And let me just, those of you who haven't written your names, but I believe at this point you have, please do it now, because I will stop the recording. Once I stop the recording, I will lose everything. So everything in the recording will be available. All right, let me start the recording now.